Hi, and welcome back to my channel. Today, we'll dive into the second step of machine learning process, which is data exploration. Data exploration involves describing, visualizing, and analyzing data to understand it better. This stage helps us answer questions like the number of rows and columns in the data, the type of data we have, and whether there are missing, inconsistent, or duplicated values. In machine learning, we use specific terms to describe the structure and the nature of our data. The term instance refers to a row of data, representing an individual example of the concept embodied by the dataset. A dataset comprises multiple instances, which are also known as records or observations. In this context, each employee is represented by an instance. Each instance is characterized by a set of attributes or features. A feature refers to a column of the data and represents a property or characteristic of an instance. Features are sometimes called variables. For instance, in our employee example, attributes like employee name, salary, department, position, and years of experience are all features of an employee instance. Features can be categorized based on the type of data they hold. A feature can be categorical, meaning it holds data in discrete form with a limited set of possible values. In our example, employee name, department, and position are categorical features. Alternatively, a feature can be continuous, holding data as integers or real numbers with an infinite number of possible values within a range. In this case, salary and years of experience are continuous features. Other examples of continuous features include attributes like temperature, height, weight, and age. It's important to note that not all numerical values are continuous. For instance, a Likert scale from 1 to 5 is categorical, not continuous, as it doesn't have an infinite number of possible values between its bounds. Features can also be categorized by their function. In supervised machine learning, we use a set of features known as independent variables to predict another feature known as the dependent variable. If the dependent variable is categorical, it's called the class. If it's continuous, it's called the response. In our employee example, if we're predicting employee performance based on their attributes, performance would be a class if it's categorical. Example, high, medium, or low. Or the response if it's continuous. Example, a performance score. The dimensionality of a dataset refers to the number of features it contains. Higher dimensionality means more detail about each instance, but it also results in higher computational complexity. Sparsity and density describe the extent to which data is present for the features in the dataset. For example, if 20% of the values in the dataset are missing or undefined, the dataset is 20% sparse. Density is the complement of sparsity. So, a dataset that is 20% sparse is 80% dense. One of the best ways to understand your data is to summarize it by running aggregations, like mean, max, minimum, and so on. We call it running statistical measures. These aggregations are helpful in describing the characteristic of data. The pandas library provides us with several easy-to-use methods to describe and summarize data. So, let's go ahead and import the data we want to use for this tutorial. Supermarket sales, that's how we call it, and we use pd.readcsv. We add the location, correct the name. So let's run this. One of these methods we can use is the info method. Given the supermarket sales, we can use info method and see what it returns. So we get a concise summary of rows and columns in our data. From the output, we can tell that the supermarket sales data has 11 rows and 17 columns. 7 columns hold decimal values, 9 columns hold textual data, and 1 column hold an integer. Now if we want a sneak peek of our data, we can use the method head. The method head returns by default the first 5 rows of the data frame. We can choose the number of rows to show by simply choosing a number between parentheses, like only 3 rows, and there you have it. This method provides us with a high-level view of the data we're working with. Now that we know what our data looks like, we can start dive a little deeper into the nature of values. The next method we are going to see is describe method. This method returns, as you can see, describe, a statistical summary of each column in the data frame. It's important to note that the describe method results depend on the data type in a column. Let's try to run describe method on non-numeric value. Example, gender. The output tells us we have 1000 rows, 2 unique values, male and female. The most values are female with the frequency of 501. Now, to illustrate how the describe method works for numeric values, we start by selecting the column we want, for example, supermarket, unit price, and we use the describe method. From the result, we can tell that the mean, the minimum, and the max price of units are respectively 55, 10, and 99. We can also run specific aggregations for a column in the data. Pandas provides several methods to do this. For example, we can get a count of each city of sale. Supermarket. We specify the column we want to use, which is city, and we use the method value counts. The results return a list. Now sometimes it's better to return a percentage instead of a count. To do this, we only need to add one argument, which is normalized equals to. And there you have it, the percentage of sales for each city. For numeric values, we can get specific aggregations as well. For example, for unit price column, we can get the mean of sales by simply running .mean method. We can also get aggregations by group level. For example, we can get the mean sales by product line. Market. To do this, we use the group by method and pass the column in which we want to group by, which is product line. Next, we specify the column we want to aggregate by, which is unit price. And we call the method mean. Let's run this. The results are stored by product line. We can also compute more than one aggregation using the method agg. So we simply specify the aggregation we want to compute, like mean, max, and minimum of unit price for each product line. Let's run this. And there you have it. All the methods we discussed here are just the tip of the iceberg. Pandas offer many data exploration methods that you can check on their documentation site. Next, we are going to see how we can perform these data exploration using R. Now, I'm going to walk you through converting the Python-based data analysis workflow into R. As we have seen in the previous chapter, how to explore data using pandas in Python, we will discover how to do similar tasks in R. So let's dive in. First things first, we need to load the necessary library in R. So we use reader for reading CSV and deployer for data manipulation. If you haven't installed these packages yet, you can do so using install packages, or as you can see there's this warning over here, you can simply say install, and then it will go ahead and install these libraries for you. Thanks RStudio. Now let's go ahead and run this code to import libraries. So now that our libraries are loaded, we're ready to import our dataset. So let's make sure we are in the right directory. Data exploration, data, and define it as our working directory. So we'll simply use supermarket cells or just supermarkets and use the method read CSV and the name of the file. All right. Clean our environment and import the data. There you have it. So with the data loaded, let's take a quick look at the first rows to ensure everything is in order. To inspect the first few rows of our dataset, we can use the method head. This function is similar to the head function in Python. So now we say head and supermarket and we run the code. So this gives us a quick overview of the data, but to get more detailed information, we can use str function, which is equivalent to Python's function info. So str and the name of our data frame. Let's run this. All right. Let me make it a little bit bigger. So here we see the structure of our dataset, including the data type of each column and the preview of the data. All right, now let's generate some basic descriptive statistics for the entire dataset. In R, we use the method summary. The summary function provides similar statistics to what we'd get using the describe method in Python. So the name of the data frame, and let's run this. This function provides quick summary including the minimum, the maximum, the median, and the mean values for numeric columns. Sometimes you might want to focus on specific columns. Let's start by looking at the gender column. To reference a column in R, we can use the $ symbol. So using summary, we can easily see the distribution of gender in our dataset. Similarly, let's take a closer look at the unit price column. The summary function provides us with statistics such as the mean, the median, prices, and so on and so on. Next, we'll calculate the frequency distribution of a categorical column. Let's see how the product line column is distributed across our dataset. So we'll use table method, dollar, product line, and we'll combine it with prop table method to get the normalized value counts. Let's run this. And there you have it. This shows us the proportion of each product line in our data, helping us to understand the distribution at a glance. For numerical columns, we often want to calculate aggregations. Let's start with the mean of unit price column. The mean function in R is straightforward and gives us the average value. And there you have it, the mean of the prices. But what if you want to see the average unit price for each product line? We can achieve this by grouping the data by product line and then summarize it. Let's see how we can do that. Let's go ahead and run this. And there you have it. Finally, let's take a step further and perform multiple aggregations at once. We'll calculate the mean, max, and minimum unit price for each product line using the summarize function. And we can run this. There you have it, the mean, the max, and the minimum unit price for each product line. So we have successfully covered a Python data analysis script into R, covering everything from loading to performing detailed aggregation. If you found this tutorial helpful, don't forget to like, comment, and subscribe for more data science content. See you in the next video.